Hey everyone, welcome back to the channel Code with AKJ. Today is day 25 of solving Geeks for Geeks problem of the day. Today's question is sort zeros, ones and twos. So let's say the question. Here the question says given an array containing only zeros, ones and twos, we need to sort the array in ascending order. Examples here would be 0, 2, 1, 2, 0, which will be sorted in the order zeros, ones and twos. And in this example 0, 1, 0, the output would be 0, 0, 1. So they are expecting us to complete this problem in O of n time complexity and without using any extra data structure. So O of 1 in space complexity. So I've written here the array and the expected output here. So by looking at the question and the array, the brute force approach we can think of is using an inbuilt function sort, and we directly submit the function. So the time complexity here would be O of n log n. So let's use this sort function and let's see whether it gets accepted or not, or it gives time limit exceeded. So here we'll be using inbuilt sort function. Let's compile and run. Since the function is void, we don't need to return any kind of thing, so we just need to implement the function. So let's submit. As you can see, it's accepting, but it's not in our expected time complexity, so we need to optimize it a little bit further in our expected time complexity of O of n. So the next approach here would be to count number of zeros here, ones and twos, and later on we'll use an index which will start from 0, and we'll initially store the values of 0 first in the array, and then 1 in the array, then 2 in the array. Dry run here would be the count of 0 would be 2, the count of 1 would be 1, the count of 2 would be 2. So we'll take an empty array and we'll take an index 0. So we'll start from value 0 here and we'll run until or unless this count of 0 becomes 0. So the first iteration would be 0, 0, and then after finishing it, we'll run the loop till the count of 1 becomes 0. So the following array would be updated in this way, and finally we'll update the 2 in the array until or unless its count becomes 0. So in this way we can fill the array using an extra space. So this way of solving it takes time complexity of O of n and space complexity of O of n. So let's code this approach and let's see whether it gets accepted or not. So here's the code. I have taken the size of the array, taken 3 variables, zeros, ones and twos, counted their values in the array, and finally I've used no space, external space here, and I've taken the same array and updated the array, and here I have run the loop which runs from 0 to n, and until or unless their count values become 0, I have updated the array values with its values zeros, ones and finally 2. So here the time complexity would be O of n and the space complexity would be O of 1. Here if we consider a practical complexity, we have run 2 for loops. The practical time complexity would be O of 2n and the space complexity would be O of 1, as I have not used an external vector to store the values. So we still need to update this practical complexity from O of 2 cross n to O of n. So the optimized approach we use here is an algorithm we generally use to segregate 3 values. So since here the values are zeros, 1 and 2, this algorithm is also called as Dutch national flag algorithm. So let me explain that algorithm and we'll dry run this code with this example, and finally we'll write the code for this algorithm. So the algorithm I was talking about earlier was Dutch national flag algorithm. So the idea here is to sort the size of an array of size n using 3 pointers, which is low, mid and high. And this algorithm works in such a way that it divides the array in 3 different parts. The initial part would be from array of 0 to array of low minus 1. and second part would be from array of low to array of mid minus 1, and finally the last part would be from array of mid plus 1 to array of n minus 1. So in this way, this algorithm segregates the array of size n in three different parts, and since here in our case the three parts are zeros, 1 and 2, so we'll use this algorithm in our problem statement, and we'll segregate these zeros, ones and twos according to its position as mentioned below here, from array 0 to array low of minus 1, and from array of low to array of mid minus 1, and array of mid plus 1 to array of n minus 1. So the algorithm goes like this. We'll traverse over the array until or unless mid becomes less than or equal to high, and according to the value of array of mid we can have three different cases, and we can segregate these three values. So here three cases for our problem statement would be: if array of mid equals 0, we'll swap it with array of low, as we need 0 at the starting point, and array of mid becomes 1. Then we move to the next element. 1 stays at the middle part, and we'll increment the mid by 1 here to process the further subarray. And finally the third case would be if array of mid becomes 2, then we'll swap the array of mid value with array of high, as we need the 2 value at the last part present at the end of the index, and we'll decrement high pointer by minus 1 here. And since we need zeros at the initial index, we'll swap the mid value with low, and we'll increment the low pointer here by 1, and here we'll decrement the high value by minus 1, and here we'll increment the mid value by 1. So in this way, by using these three cases, we'll use Dutch national flag algorithm in our problem statement to segregate zeros, ones and twos. And finally, in this way, we'll get our expected approach of segregating zeros, ones and twos, and which will be in our sorted order. So let's code this approach and let's see whether it gets accepted or not. So before moving on to the code, the time complexity here would be O of n, as we are using a single pass, and space complexity would be O of 1, as we are not using any external data structure here. So let's code this approach. So this is a code for the national flag algorithm, where we have taken size of an array, 3 pointers, low, high and mid, and we'll run the loop until or unless mid becomes high, and we'll check these three cases. If array of mid value becomes 0, we'll swap it with array of low value, and we'll increment the mid value and low value. And second case would be if array of mid value becomes 1, we'll just increment the mid value, as we don't need to swap this one value with any of the other values. And the last case here would be that if array of mid value becomes 2, then we'll swap the mid value with the high value, as we need the 2 at the end of the array, and we'll decrement the high pointer here. So in this way, after finishing all the iterations until or unless this while condition fails, we'll get our expected position of our three values here, 0, 1s and 2s. So since it is a void function, we don't need to return anything. So let's compile this and check. Let's submit. As you can see, this problem got solved successfully as well, but here the time complexity is as expected time complexity as in our problem statement, which is O of n, and space complexity is O of 1. So this is it, guys. I hope you like this video and explanation. If so, please give it a like, share with your friends, and subscribe to my channel for more such coding challenges. Thank you. I'll see you in the next one.